What's up, everybody? Today we are starting a brand new unit on polar equations and polar coordinates. This is going to give us some further applications of our trigonometry from the last few units, okay? So today the focus is on objective number 1 of this lesson, which is just being able to plot points when you're given their polar coordinates, all right? You are used to plotting points when you are given rectangular coordinates. That would be when you're given the x-coordinate and the y-coordinate. So today we're introducing this entirely new coordinate system to you where the points are given with an r value and a theta value. So a point P in the polar coordinate system would be represented by an ordered pair of the numbers r theta, okay? When you're in the polar coordinate system, you have what's referred to as a polar axis. It's a ray whose vertex is at the pole, and the pole is your center point. It's really nothing more than the origin. It coincides with the origin from the rectangular coordinate system. So you'll notice in the picture here that you have that point labeled with the letter O. That's your pole. Again, it's just like the origin, and then you have your polar axis, which would correspond to the positive x-axis from the rectangular coordinate system, okay? Notice, if you want to plot the point P, whose coordinates are r theta, all you need to do is you rotate from the polar axis theta units. That's going to take you to a terminal ray, and then on that terminal ray you're just going to count r spaces, r units, to get to your point P. Okay, now that would be if your r value was a positive number. Notice below here, if the r value is negative, then the points plotted on the ray that is extending in the opposite direction of the terminal side of theta. Okay, so if I'm trying to plot the point of negative r theta, I start on that polar axis, I rotate theta units. That takes me to a terminal ray, but instead of plotting the point on that terminal ray, I extend it in the opposite direction and count r units that way. Okay, so let me give you some illustrations to go along with this, kind of help drive this home. All right, now you're actually getting an introduction in this illustration to the polar grid. Okay, so you'll notice the polar grid is represented with a bunch of concentric circles. Concentric circles just essentially means that they're like almost like they're parallel to one another. They don't intersect each other at all. Okay, and notice that each one of these circles is centered at the pole, right? The smallest circle that you see in the middle there, it would be a circle whose radius is 1. And then the next circle out from that would be a circle of radius 2, then radius 3, 4, and so forth. Okay? You have the pole labeled, you have the polar axis labeled. So let's say we wanted to plot the point of 3 comma pi. R is 3 and theta is pi. You notice what we'll do here is we will rotate. We'll sweep out our pi radians, and then off the terminal side of that angle, we would go 1, 2, 3 spaces out. That would correspond to the circle whose radius is 3. And that's where you place your point. Okay? Let's give you a different value here. Let's say instead of theta, I wanted like pi over 2. All right. And changes it to a decimal. 1.57 is approximately pi over 2. So I will rotate to the terminal side of that angle, and then I will go 3 units up that terminal side. There's my point. All right, now what if my point has an r value that's negative? Okay, so we'll make r -3 this time. So I'll begin the same manner as the last point. I'll sweep out my pi over 2, But then notice I end up going 3 units in the opposite direction of the terminal side of that angle to get to my point in the end. Okay? All right, let's do a little bit of this ourselves. We're going to begin with without plotting in the grid system. We're going to do this just on a white, background here. Okay, so let's start with 3 pi, and I always want to begin with putting a point down for the pole, and then here's my polar axis, and I'm just going to sweep out pi, and then off the terminal side of that angle, I'm just going to count 3 spaces, and that would be where I would place my point of 3 pi. Okay. Next one, we have 3 pi over 6. So again, draw a pole, polar axis, sweep out your pi over 6, which is 30 degrees. So let's just estimate that here. And off that terminal side, 1, 2, 3 units. Place your point here. All right, next example, -3, 3 pi over 4. Notice the R value is negative, right? So start with the pole, polar axis. If you sweep out 3 pi over 4, it's going to take you here for your terminal side. It's like 135 degrees. And since R is negative, before I could plot the point, I have to extend that terminal ray in the opposite direction and count 3 units that way. There's my point. All right, last point. Very easy to confuse this with rectangular form. So we have 2, 0. From context, we have to understand that 0 actually represents radians. Well, we know that 0 radians or 0 degrees would make our terminal ray the same position as our initial ray, right? So all I have to do is go 2 units on that polar axis to get to my point of 2, 0. Okay. All right, now let's do this using the polar grid. I mentioned when we looked at the applet that the polar grid, it coincides with the rectangular coordinate grid, okay? So what I mean by that is this line right here is coinciding with the x-axis in the rectangular coordinate system, and then this line corresponds with the y-axis. Okay, and of course their intersection point, the origin, is where you would have your pole. We mentioned that this grid is made up of concentric circles that are all centered at the pole. The smallest circle that you see in this grid would be thought of as having a radius of 1. The next biggest circle would be radius 2, and so forth. And then notice that each one of the lines that is intersecting the pole through the pole here, each one of these lines is labeled in 15-degree increments, or pi over 12 radians. All right, that's very common for a polar coordinate system to be labeled that way, in increments of 15 degrees. Okay. All right, so let's plot point A first here. It's the point 4 pi, or of course 4 180 degrees. So that is going to place us on what would be the same as the negative x-axis, and from the pole I would just count 1, 2, 3, 4 spaces out, which would correspond to the circle whose radius is 4 units, and that's where I would place my point A. Okay. Point B, it has an r value of 4 pi over 3 associated with it, which is the same as 240 degrees down here. So off of that line down in the third quadrant, I would count 4 units in that direction to get me to point B. All right, now point C, notice it has a negative r value, okay? So while the angle is pi over 6 or 30 degrees, we're actually going to have to extend in the opposite direction, which will take us to what appears to be 210 or 7 pi over 6, okay? So we're going to go from the pole 3 units along that line to get to my point C. All right, so that is how we plot points when we are in the polar coordinate system.